Okay, so today's assignment is graphing linear functions, word problems. And if we look at the name of the assignment, we can have an idea of what it is that we're going to be doing. A function is an input and output machine. A function is f of x. You're going to put numbers into the function and get numbers out of that function. They are linear functions, which means they're going to be straight lines either up, down, or sideways, or up and down. Linear, which means straight line functions. There's going to be word problems, so we're going to need to read, and we're going to be graphing them. So I'd like to review the two things that we need to know for graphing. They were, what was the triangle and what was the star? So we're going to read the word problems to identify these two quantities. Triangle is how much something changes. So slope. So when you talk about how fast something is changing, you're talking about the slope or the change. And then the star is going to be where it starts. Okay, and I added one extra thing here, which is that occasionally we're not going to have the star where it starts. Occasionally we're going to have it at some other point, the ending point, where it's 0, where the temperature is 14, and so on. In other words, there's going to be some point that we know, as well as what the slope is going to be. So please catch up with those notes. I'm moving on. You can push pause right now. All right, so our first word problem is about Rip Van Winkle. It says, Rip Van Winkle, and in case you don't know, Rip Van Winkle, there's a story of, here's a tree, and it's an old story about Rip Van Winkle, and he was a man who fell asleep underneath a tree, and he fell asleep for a long time, and his beard got very, very long. So this is Rip Van Winkle's beard because he fell asleep under a tree because he was lazy. Okay, so Rip Van Winkle fell asleep for a very long time. When he fell asleep, his beard was 8 millimeters long, and each passing week it grew 2 additional millimeters. Okay, so let's identify the two things that we know about this problem. We know something about how Rip Van Winkle's beard is changing. We also know something about where Rip Van Winkle's beard starts. Okay, Rip Van Winkle's beard starts out 8 millimeters long when he fell asleep. So he fell asleep at time equals 0, and that was 8 millimeters long. And then each passing week, it grew 2 additional millimeters. So I know something where he starts. So his beard starts at 8 millimeters long. And then how fast does his beard change? Well, his beard changes to, I'm going to say plus 2 millimeters per week. Okay, so his beard started out being 8 millimeters long. A millimeter is a tenth of a centimeter. So this is, well, it's less than 1 centimeter, 0.8 centimeters. And then it's going to gain 0.2 centimeters per week. So let's graph up and down what his beard is going to look like. So his beard starts out at 8 millimeters. So when time was 0, when he fell asleep, it was 8 millimeters. Now, the thing that's hard about this is that these graphs, you remember I told you stop counting the squares? Stop counting the squares. The squares do not tell you the slope. We're about to do a slope of 2. Now, a lot of people are going to want to make a slope of 2 like this. Put a dot here, and then count 1, 2 squares over 1 square, and then put another dot. And they're going to say, okay, that's a slope of 2, Mr. Wolf, because it goes up 2 squares and sideways 1 square. So I'm going to go ahead and write out in words so that you can't do it anymore. Stop counting squares. I'm glad that you guys have gotten that introduction to finding the slope, and it's important, but you can only count squares when these numbers over here are 1, 2, 3. But these numbers here don't go 1, 2, 3 anymore. They go 4, 8, 12, 16. They don't go 1, 2, 3. So each square is not worth 1. So you can't count the squares because each square is worth more than 1. So stop counting the squares. What are we going to do? We're going to figure out how I can go up 2 and sideways 1 on a slope triangle. So I'm going to go up, I don't know, I'm going to go up 40. I'm going to go all the way up 40 just because that's something I feel like doing. Add 40. And now I'm going to figure out, okay, well, if I went up 40, now notice that I went up 40 because I started at 8 and I went to 48. I didn't say go to 40. I said go up 40 from 8. So starting at 8, you go up 40 and you stop at 48 because 8 plus 40 is 48. That's plus 40. I never did say go to 40. I said add 40. Okay, so we're now at 48. So that's the rise. I went up 48. In other words, he gained 40 millimeters in his beard. Now, in order to gain 2, that means I need to go sideways how many? Well, I would have to go sideways 20 because 40 divided by 20 would give me 2. Let me show you what I'm talking about here. So let's put a second dot over here at 20. I'm going to run in my per week, but that's okay. And put my second dot over here. And then I'm going to connect those dots with the line, and I'm going to look at what kind of slope triangle I'm going to get. So there's my line. And then here's my slope triangle. And then I'm going to shade that in. Okay, well, what kind of a rise over run is that? Up from 8 to 40, I go up 40. And then I go sideways from 0 to 20, I go sideways 20. And now let's look at the slope. The slope is the rise over the run, and 40 over 20 is 2. In other words, I want to go up twice as many as I go sideways. So whatever I do, if I go up twice as many as I go sideways, I'm going to have the right line. So I'm going to start all the way over. Now, people are going to complain. Mr. Wolf, I already wrote all this down. Listen to me now. Leave this on your paper. Don't erase anything. I'm going to try it again, but this time I'm going to do a different rise and run, but I'm going to get exactly the same line. That's why you don't have to delete anything. I'm just repeating everything. Okay, so I still have to start my line at 8, but this time I'm going to use a different rise and run, but because the slope is constant, I'm going to be just fine. I'm going to go up 20 this time. I'm going to go up 20 to 28. Now, if I go up 20, that means I need to go sideways half as many because the rise over the run needs to be 2. So I'm going to go sideways. Let's see, what's half of 20? Half of 20 is 10. So I'm going to go sideways to 10. So I'm going to go sideways to 10. And here's my second dot. And then I'm going to connect those dots with a line. And then shade it in and have a look at what my rise run triangle is. If I go up 20 and sideways 10, so starting from here to here, that's 20 because I went up from 8 to 28. And then sideways, I went from 0 to 10. That's sideways 10. So that's 20 over 10. And that's also equal to 2. And you'll notice that actually, if I kept this line going all the way, I would run right into 48, 20, which is the line that I just erased, the dot that I just erased that you guys all complained about because I erased it. So our objective is to find the correct star and triangle, and to do that, we're going to have to set up a triangle, and the slope is going to be whatever we ask it to be. Okay, let's try this again. Raj took a slice of pizza from the freezer and put it in the oven. The oven heated the pizza at a rate of 7.5 degrees Celsius per minute. So that's telling me my triangle. My triangle is 7.5. And it reached the desired temperature of 80 degrees Celsius after 12 minutes. So I don't know, in this case, exactly where it starts. So it says 80 degrees Celsius after 12 minutes. Well, let's see. Minutes is down here, and Celsius is up and down. So it must be 12, 80. Because it's going to be 12 minutes and 80 degrees Celsius that I'm going to be putting at. So I want to put a star at 12, 80, and I want also the slope to be 7.5. So I'm going to put my star. Okay, so at 12 minutes it was 80 degrees, so that's where I'm going to put my star. This is minutes down here, and up and down is the degrees. So we've got a pizza, guys. So this is a pizza, and it's a frozen pizza. He took the pizza from the freezer, so this is a very cold pizza, and he put it in the oven. And it got hotter and hotter, and after 12 minutes, it reached 80 degrees Celsius. After 12 minutes, it reached 80 degrees Celsius. So I've got a line here that represents the temperature of the pizza. Starting at freezing, it's going to warm up all the way until after 12 minutes, it's going to reach 80 degrees Celsius. So I'm going to put my star. After 12 minutes, it's 80 degrees. So that's, oh, I keep running into my star, so I'm going to move this a little bit. So I'm going to put a star, 12 minutes, it's 80 degrees Celsius. That's way up here. Okay. All right, now, a slope of 7.5, the easiest thing is going to be factors of 10. Why am I going to choose factors of 10? In other words, why is the run going to be 10? Because 7.5 times 10 is just 75. You can also do, it looks like down here, these do go by ones, but you're going to have to go, let's go ahead and go sideways 2. So I could go down, sideways 10, down 75 if I wanted to, but because I think a lot of people are going to be confused by that, let's just go down 2. So let's just go sideways 2, sideways 2. What I just did when I went from, did I put it on 13? I did put it on 13. Probably people out there yelling at me from this group. Mr. Wolf, you put it on 13. Okay, so I'm going to go sideways 2. If I go sideways 2, well, let's see. In order to get 7.5 for the slope, I would have to go 15, because 2 over, I'd have to go 15 down. So let's see, this is 80. So I'm going to go down 15, and that's going to be 5, 10, 15 down there at 65. So 65 is going to be my second point right there. Minus 15. Or rather, this is plus 15, and then sideways 2. Okay, so this is my rise run triangle. I go from 65 to 80, that's plus 15, over 2. Let's double check that with our rise run. So the rise over the run is 15 over 2, and because I'm so good with my decimals, I know that that's 7.5, because 15 over 2 is 7.5. And so now I can connect those dots from 12, 80 down to 15, 2, and it's going to come down something like this. I think it was probably less than 0. It was probably less than 0 when it started. Okay, so now I've got a dot here at 12, 80, and then I've got another dot here, and I move my 2 dots to those 2 points. And let's double check. My star is at 12, 80. 12 minutes, it was 80 degrees, so check, I got that right. And then the slope should be 7.5. If I go up 15, sideways 2, my slope is 7.5, so check, I got that right. So now I'm going to try this again. Quinn returned home on a hot summer's day to find it sweating-inducingly hot. He turned on the air conditioner, so my slope is going to be down because I'm going to start off hot. It's going to get colder because the air conditioner is on. The room's temperature decreased by 0.5 Celsius each minute, and Quinn woke up 60 minutes later when it was 10 degrees Celsius. So I've got a star. In this case, this is kind of a generalization. It's not necessarily where it starts, it's just the point that's on the graph. And I know what the slope is for sure. So let's have a look. So my slope is 0.5 each minute. So every minute, the speed at which this goes down is 0.5 degrees Celsius every minute. And then the star is not where it starts. It's at 60 minutes later. So time is this way. So this is 60 minutes. That's going to be 10 degrees Celsius. So that's down here. So at 60 minutes, it was 10 degrees Celsius. So 60, 10. And let's move everything over just a bit. Okay, so I have succeeded in finding a point on the graph. After 60 minutes, it was 10 degrees Celsius, so I'm going to put 60 minutes, 10 degrees, which is right there. And then I want it to be going down 0.5. Well, let's go sideways 10. You remember I was telling you that sideways 10 is a good idea because it's really easy to multiply something by 10. So this is sideways 10. That would mean I would have to go up and down by 5. Okay, so because 5 times 10, or 0.5, 0.5 times 10, when I multiply times 10, I move the decimal point 1 time, so I need to go up and down 5. So if I go up and down 5, that would mean I go from 15 to 10. So that's right here. So I'm decreasing from 15, from here to here, that's from 15 to 10, that's minus 5. And then sideways from 50 to 60, well, that's 10. So 5 degrees have changed, 10 minutes have elapsed, and my slope is going to be 5 over 10, that's rise over run, which is 0.5. Which is what I wanted it to be. So the slope is 0.5. Everything is going good there. And then I put a star where I wanted it to be. And so now I can connect my dots, and I've got the graph of this line. This is the graph of a line. This is the graph of a line that has a point at 10, 60, 10. At 60 minutes, it was 10 degrees, and it has a slope of 0.5. Okay, I'm going to do the same thing here for Mr. Mole. Mr. Mole's burrow lies 5 meters below the ground. Okay, so that's where he starts. He starts out 5 meters below the ground. And then what happens from there? He started digging his way deeper into the ground. So he's going to start here. He's going to go down into the ground, going down this way, descending 3 meters each minute. So that tells me my star and my triangle. So he starts out 5 meters below the ground, and he's going to descend at 3 meters per second. So that's minus 3. So he's going to be going down. The reason why those are negative, he starts out below the ground and it gets deeper every minute. Okay, so let's see, I'm going to put a star where he starts. He starts out 5 meters below the ground. And then there's still a lot of people having a hard time with this minus 3 business. So if I went sideways 1, he would go down 3, which is right about there. Sadly, I want the point to be exactly on one of these grid lines, and so I can't go over 1 down 3. So what could I do? I need to go over an amount that's going to give me a multiple of 5. So the easiest thing to do is to always go over 10. So if you just go by tens, then you know what you're going to do. You're going to multiply this times 10, and now you know what your rise needs to be. It needs to be 30. So I'm going to go down 30, down 30. A lot of people are going to stop right there because they're going to say, oh, Mr. Wolf said to go down to 30. I never said go down to 30. I said go down by 30. So I said subtract 30 from 5. So he started out at -5 and he goes down 30 minus 30. From there, and he winds up at 35. And then he went sideways 10. So let's double check my slope. It's -30 over 10. And incidentally, this is 30. From here to here is 30. And from here to here is 10. So it's 30 over 10. So that's 3. And he started out at 5, so everything is good.